This video is going to be over the first and second derivatives and kind of like why those are important. The first derivative is going to tell us whenever our function is increasing or decreasing, and the second derivative is going to tell us whenever the function is concave up or concave down. On the review sheet, we are given the function f of x is equal to 200 plus 8x cubed plus x to the fourth. So whenever we take f prime of our x, the 200 becomes 0 plus 8 times 3 x squared plus 4 times x cubed. So we can clean that up a little bit and get 24 x squared plus 4 x cubed. And for our f double prime, or the second derivative, we're going to have 24 times 2x plus 4 times 3 x squared. And whenever we clean that up, we're going to have 48x plus 12x squared. Okay, so now that we have our first derivative, we need to set that equal to 0 to find the critical values, and those will be the points that we use to help determine whether we're increasing or decreasing. So from there we can factor out a 4x squared, and we're left with x plus 6. So we know our zeros, or our critical values, as far as what makes that 0, are actually going to be 0 and negative 6. Because if we plug in a negative 6 for x, that's going to give us 0 inside our parentheses, and 0 times anything is going to be 0, and likewise for the x squared, it's pretty easy to see that one. Okay, so we have our critical values for our f prime. Now we need to find the critical values for our f double prime. So there was our f double prime, and the same as we did for the first derivative, set the second derivative equal to 0 to find any more critical values, and out of that we can factor out a 12x, and we're left with x plus 4 in parentheses. So whenever we actually compute that, we get the critical values for 0 and negative 4. Alrighty, so those are our critical values. So what do we do from there? It's time to make a graph, or a little number line. Okay, so what I've done here is I've taken our critical values that we found and put those on the number line. And I've put the f prime and f double prime right over here to the left. So now what we need to do, just pick some arbitrary number, that's say less than negative 6. So just pick like negative 7, and you'll plug that in to the f prime for x, and so you should get a negative for that, and plug it into the f double prime as well. And as you can see down here below, when you plug that in for x, you end up with a negative times a negative, which gives you a positive. And, so now pick something between -6 and -4. Just go with -5. And you'll plug that in to the x and for the x on the f prime and f double prime. And for the f prime, you should get a negative. For the f double prime, you should get a positive. And so between -4 and 0, just pick -1. And whenever you plug -1 into the f prime for x, you should come up with a positive. And for the f double prime, you should end up with a negative. And then you need something greater than 0, so just pick 1. And whenever you plug that in for your x for f prime, you should come up with a positive. And when you plug 1 in to f double prime, you should come up with a positive. Okay, so now what that tells us, whenever our f prime is positive, or I'm sorry, whenever our f prime is negative, we're going to be decreasing. And when f prime is positive, it's going to be concave up, which basically looks like that. And so we're still decreasing and concave up, and decreasing because of the negative f prime, and concave up because of the positive f double prime. And for the -1, since we're positive, we are increasing, and since we're negative, we're down. So we're going like that. And then positive, positive, increasing up. Should look like that. So that's it for number 1, and we'll go on to number 2.